Hello student, today we will discuss about or we will start the new module that is the bridge engineering. So today we will just give you the idea about the bridge engineering, what are the various type of bridges, what are the history of the bridges, what are the various type of the what is superstructure, what is substructure, what are the load should be considered or needed to be undertaken during construction of the bridges, what are the various factors to be considered during the construction of the bridges. Just a brief idea about the bridge engineering. So before going to start the session, let me introduce myself. Myself, Dr. Debasish Das. I am the assistant professor of civil engineering department of JS College of Engineering. Here is my WhatsApp and mobile number and email ID is given. So for any query, you can contact me with the given details. So basically, we are discuss about the. So this is the brief about the syllabus content. So this thing will be covered in phase wise or the lecture wise. So basically, the definition and the basic forms of the bridges, various components of the bridges, classification of the bridges, the short history of the bridges, development of IRC load, analysis of the IRC load, impact factor, other loads to be considered, and importance of the hydraulic factor in the bridge design. So what is bridge? So we are talking from the beginning, we are talking about bridges. So what is bridge? So a bridge is a structure that permits us to cross over an obstacle. Suppose we lay a plank across a brook. If we have a bridge, if the plank is thin in relation to the to its length, it is sagged. In fact, it is too long, it will collapse. This shows that we must consider the weight of the bridges itself. Means suppose there is a connection in between the two portion of the river or the two portion of any body. Means basically bridge is basically reduce or to create something to eliminate the gap. Now this process of elimination, during this process of elimination is called as the bridging, means bridging the gap. Now this bridge, the bridge should be made up of with any material. It may be wooden, it may be steel, it may be glass, any material. So the self weight of the bridge is one of the important factor we need to be keep at the first priority while we design for the bridge. Next is the if we stand at the middle of the plank, it sag even more. So we must provide for the weight of whatever our bridge is designed to carry the live load. So the dead load, the live load, like dead load means the self weight, live load means the carrying load, the user's load, and also when you walk across the plank, it becomes under your illustrated the effect of moving live load. And finally the wind load, whatever wind will be their effect on the bridge, that we also needed to be considered. So the classification of the bridges, so functions is aqueduct, viaduct, highway, and the pedestrians. In this areas the bridges are used. Materials for construction, the reinforced concrete, pre-stressed concrete, steel, composite, timber, etc. Form of superstructure, the slab, beam, truss, arc, suspension, cable state are the form of the superstructure. Now what is superstructure, what is substructure, we will discuss. In interspan relation, the simple and the continuous cantilever, the method of construction, pin connected, riveted, welded, and the span is of short span, medium span, long span, and other spans are there. And type of the service is the permanent, temporary, or the military bridges. So type of the bridge and the bridge component. So classification with respect to span. So small span bridge up to 50 feet, medium span bridge is up to 250 feet, the large span bridges of 150 to 500 feet, and extra large span bridges over 500 feet. So the basic components of a bridges, the two basic parts are substructure, include the piers, the apartment, and the foundation. What is piers? What is apartment? We will discuss. Then the superstructure. Superstructure is the consist of the deck structure itself, which supports the direct load due to the traffic and all other permanent and the variable leads to which the structure is subjected. The connection between the substructure and the superstructure is usually made through bearing. However, the rigid connection between the piers may be adopted, particularly in the frame bridges with all piers. What is the bridge? So bridge is a structure which provide a passage over a gap without closing or closing the opening which is beneath the gap. The passage may be due to railway, roadway, canal, natural river, etc. Initially, the natural available materials such as the stone, timbers were extensively used for the bridge, but nowadays artificial materials such as the cement, concrete, steel are utilized more in the construction of the bridges. So the what is the history of the bridges? During the King Harshvardhan, or even before him, India appears to have a good highway system, and such highway had the number of the bridges. The Frozen, who ruled the Delhi in mid of 14th century, built a number of canal and the bridges. The Portuguese in 16th and the 17th centuries built many old arc masonry bridges in Goa. One of the oldest stone slab bridges still in use across the river of Kaveri, and at the Srirangapatnam built by the Tipu Sultan. So these are the various history. I will not go in detail. So these are the some historical bridges which are built from the ancient time from Harshavardhana to the latest. Our BRO, the Border Road Organization, has taken various initiative to build some various bridges in some hilly areas or the uh, areas which are not able to easily go to that place and easily construct the bridges. So these are the few sample ancient bridges, that is the clapper bridges, tree trunk or the stone. If you have ever visited the Meghalaya state, there is a root bridge. Root bridge means the bridges are constructed with the root of the trees. So that is very unique in nature. I have visited and I'm astonished because a huge load carrying capacity it takes, but it never fails. It is constituted of joining of the roots of the nearby trees. So it is very interesting. If you get any time, you can visit the that place, that is in Meghalaya state. That is the Roman Arch Bridge in the middle, and at the right side is the Great Stone Bridges of the China. These are the some strass bridges, suspension bridges, and pre-stressed concrete bridges. So this is the development of the bridges as per the time. Now, what is the classification of the bridges? So, classification of the bridges, first one is the masonry arch bridges. So, this is the oldest form of the bridges. So, probably the first category of the bridges should be involved. Aesthetically superior for slab bridges. Consider of arc-shaped slab supported on two opposite wall, and it was adopted earlier for a small of 3 to 15 meter in masonry and extended up to 590 meter in steel and 305 meter in concrete has been built in the world. This is the beam bridges. So when something pushed down on the beam bends. So its top edge is pushed together and its bottom edge is pulled apart. Beam bridges are horizontally beam supported at each end by substructure unit and can be either simply supported when the beams only connect across a single span, or continuous when the beams are connected across two or more spans. So this is the beam bridges. So this is the pile. You can find this is the pile, means the pillar, and here the cover is and this is the deck, and this is the pile base. So whatever will be below, so this portion is called as the superstructure, this deck, and whatever below the deck is called as the substructure. This is the pipe culvert. Consists of a pipe barrel under the embankment with protection of work at the entry and the exit. It is suitable for cross drainage flow on relatively flat terrain, and in this discharge is limited and it has a negligible maintenance. Hydro, hydrocally, uh, hydraulically short conduit which conveys the stream flow through a roadway, embankment, or past some of these other flow obstruction. So this is a culvert type bridges. So you can find out that the water are passing through this type of the bridges. This one is the slab bridges. Okay, so it is the simplest type of the construction adopt for small bridges and culverts. Span is in between 10 to 20 meter. Concrete slab cast monolithically over longitudinal girder, and number of longitudinal girdle depends upon the width of the road. Plate girder bridges span ranges of 10 to 60 meter, can be extended up to 250 meter, and it is a continuous construction. So basically, this type of bridge is used for the railway. This is a truss bridges which is span is 30 meter to 375 meters, simply supported, and for a combination cantilever combination, it is in between 30 meter to 550 meter. So this is a suspension bridge. So this type of bridges are now observed in many places. So these are the some modern type of bridge. So it is a made up of a high tensile steel cable strung in the form of a uh, of centenary to which the deck is attached by steel suspension, which are made up of steel rods, members, and the cables. Deck can be of timber, of concrete, or the steel spanning across the stiffening girder and transmitted of the load. So these are the few forces. The forces came on the bridges. So there are the anchoring forces. There are the dead load forces. There are the live load forces. So there are various type of forces are there which come on the various component of the bridges. This one is the simple cable stayed bridges. So cable stayed bridges, like the suspension bridges, are held up by the cables. However, in a cable stayed bridges, less cable is required, and the lower holding the cables are proportioning the higher layers. This is a similar suspension bridges, except that there will be no suspender in the cable stayed bridges. A number of the cables are stretched from the support tower directly connected the decking. The cable stayed bridges is the newer than the other type of the bridges. Large upright steel supports are used to transmit the load into the ground. This one is the cantilever bridges. This is a cantilever bridges is a bridge built using the cantilevers, a structure that project horizontally into space, supported on the only one end. Now the cantilever bridges are built using the cantilever horizontal beams supported on only one end. Most cantilever bridges use a pair of continuous spans that extended from opposite side of the supporting piers to meet at the center of the obstacles of the bridge crosses. This one is the arc bridges. This is a very ancient type of bridges. 1,000 years ago, Romans built the arc out of the stone, and this is a stone type of bridges. Today, most arc bridges are made up of steel or concrete, and they can span up to 80 feet, 800 feet. So this is the arc type of bridges. Arc type of bridges have a abutment at the each end. You can find out. Here is the one abutment. Here is another abutment. This abutment are provided at the two end. This one are the deck. This one is the upper chord. This one is the lower chord, and this one is the pile. So this one are the forces came on the various type of various components of the bridges. The arc is squeezed together, and this squeezing forces is carried outward along the curve to the support at each end. The supports called the abutment push back on the arc and prevent the ends of the arc from spreading apart. Movable bridges. A movable bridges is a bridge that moves to allow the passage, usually for boats and the bargages. So this one is the movable bridge. So if you see that this bridge is in position, but whenever some ships or boats want to pass under this bridge, so if the height is not sufficient, the bridges will be unlocked. So this type of bridges you can find out in Khidurpur in West Bengal, and it is rarely found in many places because rarely constructed in today's time. These are the constructions of ancient time, because at that time the height will not be up to so much so that the boats or the ships can be passed. So the based upon the structural arrangement, the eye girder bridges, the plate girder bridges, truss bridges, and the suspension bridges. So what is and the based upon the structural action or the nature of the superstructure, it is a simply supported span of the bridge, continuous span of the bridge, cantilever bridges, arc bridges, and the right frame bridges. Now, based on the connection, the riveted bridges, welded bridges, bolted bridges, and the pin bridges, and based on the floor action, the deck type of the bridges, through type of bridges, semi-through type of bridges, or the pony bridges and double deck bridges used in a rail cum road bridges. Based upon the movement of the structural part of the bridges, it is a fixed or the movable bridges. And based on the purpose of the bridges, it is a road bridges or railway bridges or the pedestrian bridges. And based on the loading, the IRC load, IRC class AA or IRC class A and IRC class B. So there are various type of bridges based on the various components. Now it is as per the based on the length. Now for the length, it is a culvert type of bridges. If the span is the length of the span, the length of the span is less than 6 meter, then it is a culvert. And if it is a 6 meter to 30 meter, it is a minor bridge, and more than 30 meters is called as the major bridge. So these are the few historical, again the historical development of the bridges. So I'll not repeat the thing. These are the some phenomenological or the periodical development of the bridges. This is a typical single span bridges. Single span means there is no connector in between the deck. So this is a single deck. This is a single deck. These are the abutment. Both side boated there is abutment. This one is the bearing portion, means the load bearing portion. This one is the approach road. This is the parapet, and this is the approach embankment. So this portion is called as the superstructure, and the bottom part is called as the substructure. So this is the basic component of the bridges. So you can find out the all the various type of the component: the apartment wall, the curtain wall, the wing wall, dowel bar, then your approach slab, end diaphragm, then the ballast wall. So all the component of a bridge deck means this is the superstructure, basic component of the bridges of the superstructure, and also few of the substructure. So these are the few component of the bridges. This is the main component of the bridges. So these are the guardrails which guarding the vehicle movement. These are the guardrails. Okay, these are the guardrails. This one is the pyre or the column. This one is the column or the pyre. This one is the pyre cap. This one is the pyre cap. This one is the pyre cap, and this one is the pyre cap. So whatever above the pyre cap is known as the superstructure. Whatever below the pyre cap is known as the substructure. So this there are the another few components, that is the bearing, pyre cap, pyre column, soffit, and the beams. So these are the few another few components of the bridges. These are again few components of the bridges. There are barrier wall, beams of the beam girder, then deck, then the approach slab, base slab, pier cap, then the wing wall. So there are all these components you can find out from these 3 and the 4 diagram. So these are the component of the truss bridges. So you can find out the various components like end beam, floor beam, vertical, bottom chord, diagonal, deck, the top lateral bracing, the top chord, the strut, the portable bracing, the end post, and the hip vertical, and the bottom lateral bracing. This is a box culvert. This is also commonly using. So these are the component of the box culvert. This is a typical girder bridges or the beam bridges. So these are the various component of the beam bridges: the traffic deck, the main girder, the pier, abutment. This pier abutment you are familiar. Now you are familiar what is pier, what is pier cap, what is abutment, what is superstructure, what is substructure. So you can easily find out from this that above the pier cap it is a superstructure, and below it is a substructure. So this is the girder or the beam bridges, the most common and the basic type. It is of 10 meter to 200 meter. This is the truss bridges. It is a simple skeleton of the bridges. It is in between 40 meter to 500 meter. This is the beam bridges. The basic beam bridges is the actual beam bridges. This is the beam bridges. Now beam bridges, a beam is a girder bridges is the simplest and the most inexpensive kind of bridges. It is the most basic form of beam bridges. Consist of a horizontal beam that is supported at the each end by the piers. The weight of the beam pushes straight down on the pier. The beam itself must be strong so that it does not bend under its own weight, that is the dead load, means the self weight, and the added weight of the crossing traffic with the live load or the moving live load, and also the wind load. When a load pushes down on the beam's top edges is pushed together compression, while the bottom edges is in tension. This is the simplest of the arc bridges. This one also arc bridges. This one is also a sample arc bridges. So arc bridges are the one of the oldest type of bridges and have the great natural strength. Instead of pushing straight down, the weight of the arc bridges is carried upward and outward along the curve of the arc of the supported at the each end. This support called the abutment and carrying the load and keep the ends of the bridges from spreading out. This is a suspension bridges, simplest form of the suspension. This is a example of the suspension bridges again. So the suspension bridges are aesthetically light and stronger. Suspension bridges can be span of distance from 2000 to 7000 feet. They are also tend to be most expensive and true to its name, the suspension bridges suspend the roadway from the huge main cables which extend from one end and the of the end of the bridge to the other end. These cables rest on the top of the high towers and are secure at each end by the anchorage. So the towers are enabled to main cables. The most of the weight of the bridges is carried by this cable itself, and instead of anchorage, the cables are spread over a large area to evenly distribution of the load. So this is the basics of the cable straight bridge. So all the load coming on this cable, they are transmitted to the deck. This is a example. This is also an example. So the cable straight bridge are the suspension. It is similar to suspension type actually. Cable type bridges may look similar to the suspension bridge, but both have the roadway that hang from cables and both have the tower. Two bridges support the load of the roadway in very different ways. The difference lies in how the cables are connected to the tower and suspension bridges. The cable ride freely across the tower, transmitting the load. So how it is looks like? So these are the typical type of another type of bridges. This one is also a simple type, but it is underwater bridges. This one is the bridges in between the glacier. From the view itself you can see the dangerous of the bridges, the elevation of these bridges. So this one is bridges you have many of you have seen in many videos, this type of bridges. This one is also a type of bridges. So these are the few sample of the bridges. This is also a cable straight bridges. You can just imagine the height of the fire or the fire cap. So this is the one of the most dangerous and technically sound bridges in the world. So what are the various IRC code are used while design of the various type of bridges? So the first code is the IRC code. The basic code is the IRC standard code. So IRC 5 1958. So it is a standard specification and code of practice for the road bridges. Section 1 general feature of design. Then IRC 6, it is 2000, the standard specification and code of practice for road bridges. It is section 2, load and stresses. IRC 22 1986, it is the standard specification and code of practice for road bridges. Section 6, it is for composite construction. IRC 78 2000, it is a standard specification and code of practice for the road bridges. It is of section 7. It is for foundation and the substructure. And IRC 83, it is a standard specification of code of practices of the road bridges. Section 9 for the piering. Then IRC 21 2000 is a standard specification and code of practice for the road bridges. Section 3 plain and reinforced cement bridges. So this is all about your bridges, means not the all about of the bridges. So this is basically the glimpses of what are the various types of bridges are there. Means so if we summarize the things, so basically bridges are various types based on its use, based on its length, based on its span, based on its load, based on its configuration, based on its flooding. So based on the various categorical division, the bridges are various type. Now the thing is that which type of bridge is suitable for which type of area, or how we design the bridges. So for design of the bridges, as we said that there are various type of codes are there. So I repeat the codes once. So these are the very important codes. So the first code is the IRC 5, as you say. See that it is standard specification and code of practice for road bridges. It is a general feature of the design. Means what are the general features in the design of the bridges? It is given in the IRC 5. In IRC 6, they basically discuss with the load and the stresses. We have discussed, if you remember, we have discussed IRCAA, IRCA and IRCB loading. So what are these A and B? That will be discussed in the separate lecture. But the code used for this loading is IRC 6, and all the loads and the stress component are designed based on this IRC 6 2000. IRC 22 is basically dealing with the composite construction. Means the combination of two type of the bridges, and in that case what are the standard values should we consider, what are the design consideration, those things will be considered at IRC 22. IRC 78, it is the foundation and the substructure, basically the substructure beneath the pier cap. If you remember, I have discussed that the above the pier cap it is the superstructure and below the pier cap it is the substructure. So IRC 78 basically deals with the substructure or the foundation. Next is the IRC 83. So basically it is the, we are discussing, dealing with the bearing of the bridges. What are the various bearing capacity of the bearing, the dimension of the bearing. IRC 21, we will discuss the plain and the reinforced cement concrete bridges. So it is specially designed for the RCC bridges. So this is all about our today's class. So this is in a summary or in a nutshell, we can say that the bridges are of various type based on the various parameter, and the various type of loading pattern are also there, and various types of IRC coding are also there for construction of the bridges. So this is all about today's class. In next class we will discuss point by point, means a topic by topic. In next class maybe we can discuss about what are the various compositions or the various terminology of the bridges. After that we can also discuss about what is the various loading pattern. Means in one lecture only we will discuss the loading pattern, and in another lecture we can also design some bridges with taking some mathematical example. So in this way we have divided this bridge engineering part in a very small lecture. So this is just the introduction of the bridge engineering. So thank you for listening, and thank you for listening all for today's lecture, and till the next class, thank you.